Welcome. Let's take a look at Chapter 7, Section 3, Simplifying Rational Expressions, Multiplying and Dividing Rational Expressions. So as you're taking notes, always a good idea to abbreviate. Simplifying rational expressions. Ask yourself, is 2 over 4 simplified? If you're unsure, use your ABC button on your calculator, 2 ABC 4. It should simplify right down to, let's see, 2 goes into 4 2 times, so I have 1/2. Again, calculator will take you right there. But your calculator leaves you a little bit in trouble when you throw in x's. So 30x divided by 10. Well, you can say to yourself, though, that 30 divided by 10, 10 goes into 30 3 times. I could do that much on a calculator. Leaves me 3x. That is simplified. So I'm guessing like elementary, middle, and hey, welcome to Algebra 2. Right? We have a rational expression. We're going to simplify this function by looking for twins. Anything on top that's identical to the bottom can be canceled. What you can't do is say I'll cancel an x here with an x here, because this is an x plus 2. It's one thing. It's one term. You can't cancel part of it with a part of another. But you can cancel an x plus 3 with an x plus 3. The whole factor for the whole factor. What's left? Well, we're just left with x plus 2. There's one difference between these two functions. This one, I canceled the x plus 3. This one is nice and easy and simple. And if I asked you to graph each of these, I would much rather graph this than graph the one I started with. Let's take a look at Desmos and see the difference between the two. There's one tiny difference, otherwise they are pretty much the same exact graph. I'm going to put the original function in, I'm going to put my answer in, and I'll be able to see that they're the same. So we have x plus 2 times x plus 3 is my original, divided by x plus 3. There it is. It is a beautiful line. My new answer, after I cancel the x plus 3's, I have x plus 2. Oh, plus. Oh, same line, right? Well, almost. There is a slight difference. This here is a line. The y-intercept is 2, the slope is 1. Y-intercept is 2, I go up 1 over 1, up 1 over 1, up 1 over 1, I have all my points. And if I backtrack, I can see all those different points that make it up. Including, I have like, -3, -1. My original function, though, it looks the same until I get to that -3. Then it tells me it's undefined, and it's showing an open circle. It's showing a hole in the graph. And we'll be learning how to find those holes, how to graph them. But what it comes down to is, I have this factor here that I canceled out. When I canceled it, it made a hole in my graph. It doesn't show up on my new function because Desmos doesn't know that there used to be a hole here. We canceled out the hole. So we have to account for that somehow, though. And that would be saying that my domain, x, does not equal a certain number. What would that number be? Well, let's take that thing that we canceled and let's solve it. X plus 3 equals 0. -3 minus 3, x equals -3 is where the hole is going to be. That's why my graph is discontinuous. There's a hole in it. So my domain, x cannot equal -3. If I plug in -3 here, well, -3 plus 3 is how much? -3 plus 3 is 0. Not allowed to divide by 0. My new function, the same graph, doesn't have that hole. -3 plus 2 would be -1. It gives me a point. So I have to account for the fact that there should be a hole by saying x does not equal -3. Just because you cancel it, that hole is still part of our function. This is just an easier thing to work with in graph, but this is our function that we were starting with, and it has a hole in it. Remember, friends, don't let friends divide by 0. No dividing by 0. 0 cannot be on the bottom of our fraction. The earth has been divided by 0. I love this one because, no, I've never had a 0 candy bar, but because somebody took the time to make a meme, thought they were being funny, they could at least spell divided correctly, right? Run spell check and make a meme. You guys are going to use Desmos to explore some excluded values, meaning what can your domain not equal? So type in the functions on your paper in the Desmos, look and see what can X not equal. Is it because there's a hole in the graph, or maybe there's a vertical asymptote? Maybe there's even a horizontal asymptote. You're going to be looking at those things though. This should take you maybe about 10 minutes. Pause your video, work with partner, come on back in 10 minutes when you're ready. Hey, welcome back. Let's simplify some rational expressions now. We have x squared plus 8x over x squared. I cannot cancel x squared with x squared. Why? Because this is an x squared plus 8x. That's the biggest mistake people want to make. They just want to cancel the x squared with the x squared. No. Before you can cancel, you have to factor. That last one that we did together, it was already factored for you. Now you're going to get the fun factoring. So I'm looking at the two things up top, x squared plus 8x. They both have an x. If you're not seeing that, here's what you can do. This is x times x. This is 8 times x. They both have an x. I'm going to pull that x out. When I take that x out, take out one of these, I can clearly see I have x plus 8 left. On the bottom, this is an x squared. I might want to break this down as an x times x. And the reason being, well, I have a single x up top that I could now cancel with one of the x's that's on the bottom. So let me cancel this x here with either one of these here. And our new simplified function, x plus 8 divided by x. Now remember before I said just because something cancels, it still doesn't exist in our function. We still have a problem there. If it cancels, it usually makes a hole in the graph. The trouble is we canceled that x and there's still another x sitting down here. So does the x that we cancel make a hole, or does the x that's still on the bottom overrule it and make a vertical asymptote? There's one way to find out. Either way, we're going to say our domain, take this x, either one, doesn't matter, they're the same. Let's set it equal to 0 and solve. X equals, oh, it's already solved. My domain, x does not equal 0. I cannot plug in 0 here, here, here. I'll get 0 divided by 0. Not allowed to divide by 0. I can't plug in zeros here. I still can't plug in 0. 0 plus 8 is 8 divided by 0. Can't divide by 0. There's something wrong with our graph here. Let's put our original function, let's put our new one in, and see if we can tell what's going on. Original, x squared plus 8x. Divide, oh no, it wants to divide just the 8x. Yeah, you probably need some parentheses there. Divided by x squared. There's my function. Oh, it's an inverse variation, it's rational. My new one, 8 plus x divided by x. I'm confident my answer is correct because the two graphs are the same. But either one, I can clearly see that there is no hole in the graph. There is a vertical asymptote when x equals 0. You cannot have 0 in the bottom of a fraction. Not a hole this time, it is a vertical asymptote because it's still left in the bottom. Can't have 0 in the denominator. Next one. Oh my goodness, the factoring is getting tougher. This is why we've been practicing some factoring. Let's see what the top has in common, and let's see if we can figure out the bottom. Alright, I'm going to cheat a little bit, leave some room here. Thinking about x squared. Well, x squared is x times x, and 2x is 2 times x. What do they have in common? Well, they both have an x. So let's factor out that x. Take out an x from each of them. Take out an x here with an x here. And we have x plus 2. You can always use your distributive property to double check. X times x is x squared. X times 2 is 2x. The denominator, looking at these, I don't see anything in common. This is x times x. This is negative 1 times x. This is negative 1 times 6. They have nothing in common. Or you could say even 2 times 3, as long as one of them is negative. They have nothing in common. They don't all have an x. They don't all have a number that divides out. So instead, we're going to start thinking of things that multiply to 6. 1 and 6, 2 and 3. Now, one of those numbers has to be negative to get negative 6. And when we put them together, we're looking to add up to negative 1. So multiplies to negative 6, adds to negative 1. Negative 1 plus 6 would be 5. That doesn't work. Let's switch and make that negative. That adds up to negative 5. That doesn't work. Negative 2 plus 3, that's 1. Well, I got the right number, but the wrong sign. So we'll make the 2 the positive, the 3 the negative. This is x plus 2, x minus 3. Looking for twins, looking for things that are the same exact factors. X plus 2 cancels with x plus 2. The whole factor with the whole factor. What's left up top is x. What's left on the bottom is x minus 3. We have simplified our function, but there are still two things that cannot be in our domain. The first one comes from here. I factored and I canceled an x plus 2. Set it equal to 0. There is a hole in the graph when x is negative 2. My domain, x does not equal negative 2. And there will be another one. Let's look at the bottom. What's still here? X minus 3. Set it equal to 0. Add 3 to both sides. X equals 3. That cannot be in my domain. If I did 3 minus 3, I'm dividing by 0. That's an asymptote. It's a vertical asymptote. The one that canceled is the whole. The one in the denominator that didn't cancel is the vertical asymptote. The line that you can't cross. Literally a hole in the graph where a point should be versus a line that we cannot go through, touch, or cross. How about you take a minute, you try, pause your video, but see if you can factor and cancel anything. Then when you're ready, unpause it, check your work. Welcome back. Looking at the top, x minus 3, there's nothing they have in common. There's no square. We cannot factor the top in any way. We'll simply say x minus 3. The bottom, this is what we've been practicing lately. We had the difference of two perfect squares, x squared minus 9. Nothing in common. They don't both have an x. They don't both have a number that divides in evenly. But what we can do is factor x plus and x minus. X plus 3, x minus 3. 3 times negative 3 is negative 9. 3 minus 3 cancels out. No middle term. Are there any twins? Same exact factor on top and on bottom that we can cancel? Well, yeah, x minus 3 cancels with x minus 3. And what's it leave me? Well, I don't see anything left up top. There can always be a factor of 1. You have to have something up there. If everything cancels on top, You need a 1 at least. Why? Because this x plus 3 has to be on the bottom of our fraction. There's got to be something up here for this to still be on the bottom. Here's my new simplified function. I could plug numbers in, graph pretty easy. This is hard to graph. This one will be a piece of cake. We'll just make a table and plug in some numbers at some point. We canceled an x minus 3. It still cannot be part of our domain now. Let's solve it. Add 3 to both sides. X equals 3. This is a hole in the graph. Why? Because it canceled. My domain does not include positive 3. Is there anything else in the denominator down on the bottom where we can't have 0, right? That's the whole reason we're doing this, because we can't plug numbers in and get 0. 3 minus 3 would give us 0. You can't have 0 on the bottom. Is there anything else that, well, yeah, this here, x plus 3, set it equal to 0. X is negative 3 is a vertical asymptote. The line that we can't cross, touch, or go through. So my domain does not include 3. There's a hole. Yes, it canceled. There's still a hole there. Does not include negative 3, because if I plug in negative 3 here and add 3, I get 1 over 0. Can't do that. Here's my answer. 1 over x plus 3, with the restrictions that 3 and negative 3 are not part of my domain. They are excluded. What was Sir Isaac Newton's favorite dessert? Pause it if you don't want to know right away. It was apple pie. Thought these buildings were interesting, so somebody put a little caption to it that says, "Hug me." Doesn't it look like they're hugging? But we're building. Don't matter, just hug me. Okay. But it does. They're kind of funny looking buildings. Looks like they got little arms wrapping around each other there. What's the official reptile of Pi Day? I know, Pi Day was last week. Official reptile of Pi Day. Think of reptiles. Okay. The python. Very good, you got it. You and your group, you'll take about 15 minutes to simplify some rational expressions, and then when we come back, you have a little bit more with your notes to finish up. I'll come back. Multiplying rational expressions. Let's take a look at 2 different ways to do the same fraction. You don't need to necessarily write these down. It's leading us into being able to do this with x's, right? This is elementary. We can use a calculator on these. One way to do it is simply multiply straight across. 3 times 10 is 30. 5 times 9 is 45. We put it in our calculator and we reduce it down. Let's see. They're both divisible by 5 because they end in 0 or 5. I could divide both of them by 5. 30 divided by 5 is 6. 45 divided by 5 would be 9. Oh, this is 2 times 3 and this is 3 times 3. I could divide them both by 3 and I get 2/3. It's kind of a long way to do it. The way that I learned to multiply fractions, because we weren't allowed to use calculators, we had to use this thing up here, was we looked for factors that divide into each other. So 5 will divide into 10 2 times. And then 3 will divide into 9 3 times. So when we're done, we just get our 2/3. That's the same kind of idea we're going to do, but with algebra. This one right here. Leave yourself a little bit of room above and below, because we're going to factor as we go so we can cancel things out. All right? Leave room above, leave room below, multiplying rational expressions. Along the way, we always look for anything they have in common. If it is a trinomial, they need to all have an x, or a number that divides into each of them. Has an x, doesn't have an x. There's no number that goes into each of those. So we look for factors of 2. Can you think of anything that multiplies to 2? Well, 1 and 2. Does it add up to negative 3? It does if you make them both negative. Does that still multiply to positive 2? Yeah, a negative times a negative is a positive. So this would factor to x minus 1 times x minus 2. Let's go down below. 3x plus 6. There's no x squared. It's not a trinomial like the one above with 3 terms, but they do have something in common. This is 3 times x. This is 3 times 2. You said 3 both times. They have a 3 in common. 3 times x and 3 times 2. Top right, x squared minus 36. We don't have a trinomial, but what we do have is a difference of 2 perfect squares. Something squared minus something squared. What would it be? Well, x plus 6, x minus 6. That's why we practiced those last week. And then our last pair over here, we've got x squared plus 5x minus 6. We have a trinomial again. Nothing in common. They don't all have an x. They don't all have a number. So we start thinking of things that multiply to 6. Multiplies here, adds here. Well, multiplies to negative 6 technically, right? Let's just make some factors first. Multiplies to 6. 1 and 6, 2 and 3. How do we get a negative? One of these numbers has to be negative. And when we're done with it, we need to add up to positive 5. One of these two negative adds to 5. Or one of these two negative adds to 5. Well, it's not going to be negative 2 and 3, or 2 and negative 3, because that's going to give you 1 and negative 1. But negative 1 and positive 6 will work. X minus 1, x plus 6. We have factored. We're done with the original problem. We don't need it anymore. We have 4 factors up top. We have 1, 2, 3, 4 things on the bottom, and we're looking for twins that can cancel out. Anything up top that's identical to anything on the bottom. What can cancel? Well, I have an x minus 1 that can cancel with an x minus 1. It will still make a hole in the graph. Add 1 to both sides. Any other twins that cancel out? Yeah, x plus 6 cancels with x plus 6. Hey, guess what? We have another hole in the graph. Take away 6 from each side. So we have a hole at 1, we have another hole at negative 6. 2 points that are missing in our graph. Are there any other factors that are identical, twinsies? 1 up top with 1 on the bottom. No? All right, so what is our answer? Our answer would equal x minus 2 times x minus 6 over, those canceled, 3 times x plus 2. That's not the same thing. Adding 2 is not the same as taking away 2. These are not the same factor. Are there any other factors that didn't cancel, like these canceled and make holes, right? Is there anything else in the denominator down below with an x that we need to set equal to 0 because it's going to turn into an asymptote? Well, this x plus 2. This is going to be a vertical asymptote. It didn't cancel, and it's in the denominator. Minus 2, minus 2. So we have a line at negative 2, a vertical line that separates our graph into multiple pieces. We cannot cross that line. Why don't I take the 3 and set it equal to 0? No x, right? It's got to have an x. Give it your best shot, multiply, but by doing that, that means you got to factor before you try to cancel. Good luck, guys and gals. Help each other. See you next class.